Welcome to Math with Mr. P. Today we are doing 6th grade math, chapter 6, lesson 5. We're going to be talking about algebra properties today. Things we're going to be covering are what is a property, the commutative property, the associative property, the identity properties, and equivalent expressions. So let's go ahead and dive right into the real world link here. Angelica and Nari are baking cookies for a bake sale fundraiser. Angelica baked 6 sheets with 10 cookies each, and Nari baked 10 sheets with 6 cookies each. How many total cookies can Angelica bake? So, if Angelica is baking 6 sheets with 10 cookies each, we are multiplying. Let's see if our digital whiteboard will let us write today. There we go. 6 times 10 is 60. She will have 6 sheets of cookies with 10 on each sheet. She will have 60 cookies. On the flip side, Nari is baking 10 sheets with 6 cookies each. Still going to be 10 times 6. She will be baking 60 cookies as well. What did you notice about your answers for exercise 1 and 2? They're basically the same question, and they give us the same answer, whether it's 6 times 10 equals 60 or 10 times 6 equaling 60. Basically, what this boils down to is the commutative property. The order in which two numbers are added or multiplied does not change the sum of their product. So we're going to go take this to a different whiteboard. Using the same example, 10 times 6 or 6 times 10, the order in which the multiplication happens doesn't matter. It's still the same answer. The same goes for addition. If I do 7 plus 3, that will equal 10. Or if I do 3 plus 7, that will also equal 10. This is known as the commutative property. The order in which the numbers are added or multiplied does not change the sum or the product. So addition and multiplication, the order in which the process or the numbers are for addition and multiplication does not matter. It will still be the exact same answer. And remember, this only happens with multiplication and addition. This does not happen with division or subtraction. For example, if I do 10 divided by 2, that will equal 5. 2 divided by 10 does not equal 5. This will equal something completely different. And I can show you exactly what it'll be. 10 will not go into 2, so we put a 0 and a decimal, bring down a 0. 10 can go into 20 twice. And 10 divided by 2 will equal 0.2. These are two completely different outcomes. They are not the same. So division cannot be done in any order. So division is not something that will be involved in commutative property. And likewise, subtraction. 10 minus 5 will equal 5, but 5 minus 10 will not equal 5. 5 minus 10 technically will actually equal negative 5. Therefore, subtraction and division, not commutative. So when you think of the commutative property, I'm just going to do commutative. Commutative property will involve multiplication and addition. It will not involve division and subtraction. They are not commutative because the order in which we multiply and add does not matter. It will still be the same answer, but the order in which we divide and subtract does matter. It will completely give you a different outcome. The associative property. The way in which three numbers are grouped when they are added or multiplied does not change their sum or their product. So associative properties are related to the commutative property, but in this case, we actually are talking about 3 different numbers. The order in which addition and multiplication happens with 3 numbers also does not matter, and that is the associative property. So, for example, 2 times 3 times 1 versus 1 times 2 times 3. These will give us the exact same answer no matter what the order is. 2 times 3 is 6, times 1 is 6. 1 times 2 is 1, 1 times 2 is 2, times 3 is 6. And I can even go a step further and say 3 times 2 times 1, and this will still be 6. 3 times 2 is 6, times 1 is still 6, and I will get the exact same answer regardless. The same thing can happen with addition. It doesn't matter what the order is that you add, it will all still be the same outcome. So let's do 5 plus 6 plus 4. This will be 6 plus 4 is 10, plus 5 is 15. If I did 4 plus 6 plus 5, it would still be 15. 4 plus 6 is 10, plus 5 is 15. If I did 5 plus 4 plus 6, 5 plus 4 is 9, plus 6 is still 15. And I know over here I grouped this together just because that's how my brain works. I like grouping 6 and 4 to be 10, but watch. 5 plus 6 is 11, plus 4 is still 15. So the associative property is exactly like the commutative property. The only difference is they're talking about 3 or more numbers, 3 plus. So the associative property is talking about 3 numbers grouped in addition or subtraction. Commutative property is talking about just 2. The identity property is the sum of an addend and 0 is the addend. The product of a factor and 1 is the factor. So let's go ahead and put this in a little bit easier terms. This is going to be dealing with 0 and 1. This is also going to be talking about addition and multiplication. Basically what it's saying is anytime you add a number or 0 to any number, it's still that same number. So let's go ahead and put that in our notes. Anytime you add 0 to a number, the answer is just that number. It doesn't change. So if I could add 0 to 1,000,000, it would still just be 1,000,000. Add 0 to 5, it would still be 5. Adding 0 doesn't change the answer. That's the identity property for 0. The identity property for 1 is any number multiplied by 1 is still just that number. It does not change. I said does not instead of doesn't over here. It's fine. So any number multiplied by 1 is still going to be just that number. Multiplying by 1 does not change that number. And you guys witnessed that in your example when I did 3 times 2 times 1. It was still 6. Didn't matter where 1 was, it was still 6. So again, the identity properties, and they say properties because there's 2 of them, one for 0 and one for 1. The adding of 0 to a number doesn't change that number, and the multiplying of a number by 1 does not change that number. Properties are statements that are true for any number. The expressions 6 times 10 and 10 times 6 are called equivalent expressions because they have the same value. This illustrates the commutative property. So any expression that basically equals the exact same thing are going to be equivalent expressions, meaning they equal each other. They are the same. So if I were to ask you to give me an equivalent expression of 5 times 3, your answer should be 3 times 5. It's the exact same answer. It's going to be 15. They're equivalent expressions. 3 plus 7 plus 4 will equal 14. Another equivalent expression of this would be 4 plus 3 plus 7, or 7 plus 3 plus 4. These are all equivalent expressions because they will all equal 14 no matter what. This over here is highlighting the commutative property because we are using 2 numbers. This over here identifies the associative property. My handwriting is terrible on here. I just want to make sure I spelled it correctly. Associative property, because this indicates 3 numbers. And again, the associative and commutative properties can be related to multiplication and addition respectively. I could do a commutative example with addition, and I could do an associative example with multiplication as well. Examples. Determine whether the two expressions are equivalent. If so, tell what property is applied. If not, explain why. They're saying that 15 plus 5 plus 8, and then 15 plus 5 plus 8 with different parentheses here. So I'm going to reread this. It's saying 15 plus 5 plus 8 in parentheses, and in parentheses 15 plus 5 plus 8 outside of parentheses. The numbers are grouped differently. They are equivalent by the associative property. And remember, this is associative because there are 3 numbers involved. Use an equal sign to compare these expressions. So right here, these two are equal because it doesn't matter based on the parentheses. Yes, we have to do what's in parentheses first, but the order in which we're adding, since these are all being added, the order in which we do it doesn't matter. And parentheses are involved, that also doesn't matter. Parentheses just tell us what we need to do first, second, third, but with addition and multiplication, doesn't matter which 2 numbers you add first, second, third. We could literally group these numbers and not follow the order. I could do 15 plus 5, which is 20, plus the 8, which will equal 28. I could do 5 plus 8, which is 13, then add 15 to it later, which will still be 28. You can group how you want. Now, I know in order of operations, it technically tells us to do what's in parentheses first. Yes, we should get into the practice of doing that, but when you see just straight addition or multiplication, be aware that it doesn't matter. It's not going to change the outcome. It's when other operations are involved that, yes, we definitely need to make sure we're doing what's in parentheses first. But just because they're rewritten differently here does not make them different. They are both equal. They are both equivalent expressions. Number 2, we have 20 minus 12 in parentheses, then minus 3, and 20 minus, and in parentheses, 12 minus 3. These are not equivalent at all. Remember, the associative and commutative properties are only going to work when there's multiplication and addition involved, and that's it. Only multiplication and or division, multiplication or addition. We don't want to mix the two up. Therefore, this is not going to work because the subtraction is happening. Now, let me walk you guys through this. 20 minus 12 minus 3. Let's go ahead and do this in a different page. So in parentheses, we have 20 minus 12, and then minus 3 if I wrote that correctly, and then 20 minus, and in parentheses, 12 minus 3. Okay, we're going to do what's in parentheses first. So 20 minus 12, that will give us a new expression of 8 minus 3, which when I do that will equal 5. Over here, I must do what's in parentheses first. 12 minus 3, which will give me 9. So 20 minus 9, that will eventually give me 11. 2 completely different answers here. The order in which we subtract does matter. It does matter. And I did have to follow parentheses here because, again, these are all subtraction problems, so the order in which I did it did matter. If I had done 20 minus 12, then minus 3 down here, I would have got 5, but that's not what I needed to do. I needed to do what was in parentheses first. So I get a completely different answer, even though the 20s are in the same spot, the 12s are in the same spot, and the 3 is in the same spot. Just the shifting of the 2 parentheses makes this a completely different outcome. Not to mention the order in which we subtract is important. All right, let's see. We are going on 14 minutes. We're going to go ahead and wrap this up pretty soon. We did these examples. 34 plus 0 and 34. These are both equivalent expressions. Even though 34 is just by itself, there's no equal sign. So yeah, it kind of still is an expression. It's weird, even though they told us that expressions needed to have some sort of operation. But because we're comparing the two in this case, yes, they are equivalent. I would still be able to argue they're not expressions because it's just 34, but that's neither here nor there. They are equivalent because remember, 34 plus 0 based on the identity property just equals 34. So they are equivalent. 20 divided by 5 and 5 divided by 20 are not going to be equivalent because remember, the order in which we divide does matter. 20 divided by 5 is a completely different answer than 5 divided by 20. Therefore, that is not equivalent. On your homework, you don't have to put what property it doesn't apply to because it doesn't apply to any property. But for these, you would have to identify what property it is. Since it's 34 plus 0, it's the identity property of 0, or just put identity property. All right, we are going to do this got it, and then I want to say we are good to go. So 5 times, and in parentheses 6 times 3, and in parentheses 5 times 6 times 3. I can tell you right off the bat, this is going to be equivalent. They are, because the order in which we multiply, since if you can see, every single one of these is being multiplied. There's no other operations involved. And the parentheses don't make a difference when we multiply or add. It's still going to be the same thing. 5 times 6 would be 30, times 3 would be 90. Every outcome will be the same. Each outcome will be the same. Therefore, these are equivalent. And the property that makes them equivalent is the associative property, since there are 3 numbers. Therefore, for A, they are equivalent, and they are equivalent by the associative property. We don't want to say commutative here because there's not 2 numbers. If there were 2 numbers, it would be commutative. But because there's 3, it is associative. And then B, right off the bat, we can tell it's not going to be equivalent because there is division going on. And 27 divided by 3 is a whole lot different than 3 divided by 27. Therefore, for B, they are not equivalent. And I don't really need a property identifying it, but since there's 2 numbers, it would technically be commutative property. But it's not, because commutative property is only for addition and multiplication. All right, and I know that was a lot in a very short amount of time, but as always, if you guys have any questions, comments, concerns, the comment section is down below. For those that are in my class, you can message me on Teams or email me. As always, this has been Mr. P, and I will catch you guys on the next lesson.